This is the review for the 9.5, 9.6 quiz. The entire review is no calculator, and the quiz is no calculator as well. We practiced our calculator problems just to help us with the AP exam. So first we need to be able to graph each polar point. So remember, the first thing you do is face the angle that you're looking at, and the second thing you do is walk forward or backward. That depends on if r is positive or negative. All right, so we face pi over 6, which is this line right here, and we walk forward 1, 2, 3, 4. We're going to label that with an A. And then we face pi over 3, which is right here, but we walk backward 3 units. So you should be on the same pi over 3 line there. So this is 4 pi over 3. We're going back 1, 2, 3 units. So there's point B. And then we're going to face pi and go forward 1 for point C. We're going to face 11 pi over 12. So here's pi over 12. 11 pi over 12 is just short of 1, right? Because 1 pi would be 12 pi over 12. So that's right here, 11 pi over 12. And we're supposed to go backward 4 units. So follow that pi over 12 line down here, and you're going back 1, 2, 3, 4. So there's point D. Point E says face negative pi over 4. Well, negative pi over 4 is down in the fourth quadrant. And we're going to go forward 1, 2, 3, 4, 5 units because r is positive 5. Face negative 4 pi over 3. So regular 4 pi over 3 is in quadrant 3. You rotate around 3 quadrants. Negative 4 pi over 3 should also rotate around 3 quadrants in the other direction. So it's right here. You're facing 2 pi over 3 if you're facing negative 4 pi over 3. And then you're walking backward 2 units. So 1, 2. So I'm on the 5 pi over 3 line. That's where F is going to get placed. And then we're facing pi over 2, but going back 1, 2, 3, 4. Here's G. And face 5 pi over 12. Again, that's almost 6 pi over 12. 6 pi over 12 would be pi over 2. So 5 pi over 12 is right here. Oops, I didn't mean to write H there. So that's 5 pi over 12. And you can also get that by counting. 1 pi over 12, 2, 3, 4, 5 pi over 12. Anyway, and then walk forward 1, 2, 3 units. That's H. Okay, so we need to be able to plot polar points. In the beginning, this was the first thing we learned, but remember the last thing we learned was graphing polar functions, and it's all just about correctly plotting these points. Give 2 different representations for each polar point. One needs to have a radius positive, and one needs to have a radius that's less than 0, so negative. So I think it's a good idea to sketch the angle. So maybe we'll do this, sketch. And then the second thing is to think about coterminal angles and opposite angles. So what do I mean by that? The sketch is really helpful. So face pi over 6, which I like to just kind of draw in a line here. That's pi over 6. You're supposed to go forward 7. So you're somewhere there in quadrant 1. So how else could we say to get to this point? So the first thing I do is always draw the opposite line. So the pi over 6 in the opposite quadrant there would be 7 pi over 6. So one equivalent polar point that gets you, it's a different representation, but it gets you to the same place. I can face 7 pi over 6 and then walk backwards 7 units, so make r negative 7. If I do that, I'll land in the same place. So here's one representation. So I've got r negative. Now I just need r positive. So if I want r positive, I just need to face this pi over 6 angle again. So think about how else you can do that. You can do that by rotating around a negative angle. You could say instead of going up pi over 6, you could go down and around negative 11 pi over 6. And then you would still be walking forward because you're facing the correct way. You'd be walking forward 7 units. So that's an alternative. You can also just say, if I want another value where r is positive, I could just add or subtract 2 pi from this angle. I subtracted 2 pi. That's what I did mathematically here. But you can always generate other angles that way too. All right, let's sketch the second one. Face 2 pi over 3, that's here. So here's 2 pi over 3. Go forward radical 5, so you're somewhere in quadrant 2. Extend that 2 pi over 3 line down to 5 pi over 3. So to get the negative r, you could face the opposite angle. So face 5 pi over 3 so that you'll have to walk backwards radical 5 units to get back to this point. So here's one answer. And then again, I want to come up with one where r is positive. So I could just add or subtract 2 pi from this. So add 6 pi over 3, you get 8 pi over 3, or subtract 6 pi over 3, you get negative 4 pi over 3. I like to just do it visually instead of adding and subtracting, but you can do that if you want to. So I just like to think, oh yeah, this would be, if I rotated down and around to get to 2 pi over 3, that would be face negative 4 pi over 3. But because you are facing the point already, you would just walk forward radical 5. So for me, the visual works really well. If you're not quite as much of a visual person, you have to do the opposite angle thing to get the negative r, but then you can add or subtract 2 pi to the positive angle and you'll get another answer. Or to the angle with the positive r, excuse me, and you'll get another answer. Right, face negative 3 pi over 4, which would be like down here. So we're calling this negative 3 pi over 4. Its opposite angle is pi over 4, and you were supposed to go forward 1. So another way to do that is to face pi over 4 and go backward 1 unit. And then on this one, they provided the negative angle instead of the positive, so you could just tell me, what is this positive angle? What is this positive if it's in the pi over 4 that's in quadrant 3? It's 5 pi over 4. So you could say face 5 pi over 4. And then you're facing the correct quadrant and you're still going forward 1. Or what did I do there? I just added, mathematically, I just added 2 pi, add 8 pi over 4, and you would get 5 pi over 4 from that math too. Okay, convert each polar point to its rectangular form. By the way, the math on every problem we're doing here is not really that complicated compared to what we've been doing. This quiz is more about making sure that you understand the directions, like study the directions as much as, and what you have to do as much as just the formulas that we have. Because it's the same couple of formulas, you're just going back and forth. So we're going from polar to rectangular. So what I like to do here is label and remind myself that all of these are r's and thetas. And if I have r and theta, how do I get x, y, which is what rectangular form is? So again, this is in our notes explaining why this is true, but x is r times cosine theta and y is r times sine theta. Should be easy to remember because of our speed quizzes. We just have to remember to multiply in r. So the x coordinate is going to be 1/3 times the cosine of 2 pi over 3. And the y coordinate is going to be 1/3 times the sine of 2 pi over 3. So 1/3 times, what is the cosine of 2 pi over 3? This is quadrant 2. Your ordered pair for pi over 3 is this. So cosine is 1/2. And sine, cosine's negative 1/2, excuse me. And sine in quadrant 2 over here is positive radical 3 over 2. So the rectangular coordinates are negative 1/6 and radical 3 over 6. Remember, all this says is if you were to face 2 pi over 3 and go forward 1/3 of a unit, you land here. Another way to get to that point is to go left 1/6 and up radical 3 over 6. They should correspond to the same point. Okay, so same thing for each of these. So xy is going to equal radical 2 times the cosine of 7 pi over 4 and radical 2 times the sine of 7 pi over 4. How much work do you have to show for these on the quiz? I like to write it out. I think there's plenty of time, but show as much work as you need to, as long as it's some sort of work so that you can get partial credit if you make a mistake somewhere. 7 pi over 4 is in quadrant 4. So this is going to be radical 2 times positive radical 2 over 2. And sine is negative radical 2 over 2. So this multiplied together is 2 over 2. So 1, negative 1 is our final xy coordinate. So if we were to face 7 pi over 4 and go forward radical 2 units, another way to get there is to go right 1, down 1. Right, let's look at this one. So if we were to face 7 pi over 6 and go back 4 units, we should land in quadrant 1 somewhere. We don't need the sketch for this, but I'm just making note of that. So the question is, how far over and how far up is that point? So it's negative 4 times the cosine of 7 pi over 6 and negative 4 times the sine of 7 pi over 6. That is negative 4 times, in quadrant 3, both cosine and sine are negative. So negative radical 3 over 2, negative 4 times negative 1/2. So that simplifies to negative 4 over 2 is negative 2 times a negative. So 2 radical 3 and positive 2. The good thing about plotting the point is it helps you make sure that you have the correct positive and negative signs. I should be going right and up to get to quadrant 1. So that's polar to rectangular. Let's go rectangular to polar. Now remember, there's only one answer for if you're getting into rectangular form. There's only one way to get to this point. Polar, there could be infinitely many answers. There's probably 2 that we're going to have most common. But because of polars, you can change out your angles and have equivalent form. So just keep that in mind. What are we doing here? We're given x, y's. Again, I think on your quiz, it would be a good idea to label x, y's. And we are trying to get into the form r theta. So remember, r is equal to the square root of x squared plus y squared. So r is always a hypotenuse, use Pythagorean theorem. And we will always find theta using tangent. You could use the other trig functions that involve r, like sine and cosine, except if you messed up r, then you're going to get the wrong answer for sine and cosine equations as well. So best to use what's given. Also, it's good to plot this point to save yourself some time. Like 0, negative 6 is down here. I don't actually need to do this math to figure out if this is 0, negative 6, what angle could I face and get to that point? I could face 3 pi over 2, because I'm trying to get r theta, by the way. I could face 3 pi over 2 and walk forward 6, or I could face pi over 2 and walk backwards 6 units. You only have to give me one of these answers, so I would guess that most of you would use the first one. But there are infinitely many representations. Just add or subtract 2 pi k to either of these. All right, for the next one, now this one, you'd be going right 2 and down 2 radical 3, so you are in quadrant 4. That's important when it helps you figure out which angle you're going to use, so that you don't always get 2 angles, since you don't always need 2 answers. Let's find r first. Square root of 2 squared is 4. When you square 2 radical 3, you square the 2 and you square the radical, so this is plus 4 times 3. 4 plus 12 is square root of 16, so r is 4. And then we need theta, so tangent theta is y over x. These are non-calculator problems, so you should get a value that is around the unit circle. So if you need to, draw your 2 ordered pairs. We know it's going to be one of these 2, right? Pi over 6 or pi over 3. So if you're having trouble thinking of that, you don't have to do it in your head. It can be hard to do it in your head. Just write it down. It makes it so much easier. So y over x, radical 3 over 1, is at pi over 3. But I want the quadrant 4 answer, so 5 pi over 3. All right, so my polar coordinate is face 5 pi over 3 walk forward r, which is 4 units. If you did 2 pi over 3, because that's where else tangent's negative radical 3, then you'd be walking backward 4 units. You don't have to give me both. Okay, this one, let's start with plotting the points here. So negative, negative is in quadrant 3. All right. Notice that these are the same value, so, and they involve radical 2's. So it's a pretty good guess that theta is 5 pi over 4. But you can double check that if you want to do the math behind it. What about r? So again, you can kind of see what r needs to be just in the problem. Like normally this point would be radical 2 over 2, radical 2 over 2. So you could just puzzle out what r is, the fact that it's going to be 40. Or you could square these. We should know that 20 squared, so 2 squared is 4. 20 squared is 400 times 2, plus another 20 squared, 400, times radical 2 squared. 800 plus 800 is 1600. And we can square root that, right? That's 40, right? Because the number of zeros you have in a thing is what, like 40 times 40 will have 4 times 4 with 2 zeros, all your little elementary school tricks. So here's 40, and my polar coordinate is face 5 pi over 4 and walk forward 40 units. Also the 5 pi over 4, it would be tangent theta equals negative 20 radical 2 over negative 20 radical 2. That's 1. And again, I know it's quadrant 3 because of plotting the point and seeing which way it was facing. Okay, I'm going to stop this video here, and then the second half of the review we will pick up with in the next video.